Okay, so this says find the real zeros using the steps just outlined, and we're going to go ahead and find the zeros for this polynomial, which has 1, 2, 3, 4, 5, 6 terms. So remember, it has a degree of 5, which means it has a possibility of 5 zeros. And the first thing is Descartes' rule of signs. So I just abbreviated. The first thing we need to do is find how many times the signs switch. We already got our positive. We're going to look for our positive combos here. So positive to negative, there's one switch, remains negative but turns positive here, that's another switch, remains positive but flips back to negative there. So my possible positive combination is going to be 3, but remember you could also subtract 2, so it could be 3 or 1. So positive x-intercepts for this polynomial is either going to be 3 of them or there's going to be 1 of them. So now let's go ahead and analyze for the negative roots. I'm going to go ahead and plug in negative x. So remember, all of your odd signs are going to change. All of your odd degree signs are going to change. All of your even degree signs are going to remain the same. And of course, we're not going to mess with a constant. So when we look at the negative change in signs, negative, negative, here's where it switches to positive. There's where it is for positive. And then it flips back to negative, and then it stays negative. So my negative possibilities are 2 or none, because 2 minus 2 is 0. That's step 1. Or that's the first most important. The next thing we're going to do is we've figured out like how many positive or how many negative we could have. Now we're going to figure out what those numbers actually could be. And remember, to find the numbers that they could be, this is the p divided by q. You got to do this part. This is where you're going to really start finding the zeros of the polynomial. So our p-value is a negative 8. So all the possibilities for a negative 8 are 1, 2, 4, 8. And of course, it's going to be the positive and the negative factors on that. And our beginning value, our q value, is a 3. That's prime, so we just have 1 and 3 here. So here's going to be all of our possible zeros. It is going to be 1 divided by 1, 1 divided by 3, 2 divided by 1, 2 divided by 3, 4 divided by 1, 4 divided by 3, 8 divided by 1, and of course 8 divided by 3. So here's what we know. If I graph this polynomial, I know that it really does cross the x-axis at one or more of these numbers that we just wrote down. So to figure out what those numbers really are, we're going to do synthetic division to try to find linear factors. Okay, so I'm going to go back to what I wrote in green. Here's where the big part lies. So if you notice, the highest possibility I have of real zeros is 3 for positive. So when I look at my possible answers here, I'm going to try a positive root first. So I always start with the lowest one. I'm going to try 1. I'm going to use synthetic division, and we're going to see what the answer is. Okay, so let's try the 1s. So again, I'm using synthetic division, and I'm plugging in a positive 1. I'm going to check to make sure all of my degrees are represented, and they are. So this is going to be 3, negative 2. By the way, I'm using the positive f of x. We don't ever use the negative x. That just tells us combos. Once we do that, we're done. We don't mess with that anymore. So a 3, a negative 2, a negative 15, positive 10, positive 12, and a negative 8. Okay, let's do synthetic division. Remember, you multiply, combine, multiply, combine. And I do not have a remainder, and that makes me very, very happy because that means I found one of the zeros. So one of the x-intercepts is going to be 1. one of the factors is x minus 1. And I'm going to kind of put a bubble around that because that's some pretty important stuff that I need to look at later. So let's take a look at what the depressed polynomial is, or the polynomial knocked off by 1 degree, the quotient. So this is going to be 3x to the 4th plus x to the 3rd minus 14x squared minus 4x plus 8. So from here, what I do is I look to see if I can do factor by grouping. I would do factor by grouping if I have an even amount of terms here. 1, 2, 3, 4, 5. I can't do factor by grouping, so I'm going to have to keep going with synthetic division. So I just tried positive 1. I'm also going to try negative 1 because remember I could have a couple of negatives or none. So now I'm going to try negative 1 as an x-intercept. So here I go all over again, but I'm using this now for my synthetic division. So all of my degrees are represented. So let's do synthetic division again. And I did not get a remainder. I found another x-intercept. I got pretty lucky on this. Sometimes you do have to test a couple before you actually find things that do not have a remainder, but I lucked out. I found 2 of them on the first try. So we know that one of the other x-intercepts is a negative 1, which means x plus 1 is a factor. And that's really important information, so I'm going to bubble that in because I still have more work to do, but I need to go back and look at that later. Let's see what the quotient is. So remember, we start out with a 4, so that's going to be 3x to the 3rd. And then from here, I'm going to see if I can do factor by grouping. I do have an even amount of terms. 1, 2, 3, 4. I'm going to try to do factoring by grouping and see if it works out. So I'm going to look at these 2 factors. I can take out an x squared. So that's going to be 3x minus 2. What's next? Over here, they're both 4s. I can take out a 4. I'm going to take out a negative 4 so that my beginning terms are going to match. So a negative 12 divided by a negative 4 is a 3. And then 8 divided by negative 4 is minus 2. And that was factorable. So we're almost done answering this question. So we've got x squared minus 4 and 3x minus 2. That can go farther. So this is going to be x minus 2. X plus 2, and then 3x minus 2. So remember, oh, I'm sorry, that's off the screen. So I factored that completely. That was the depressed polynomial, the quotient, from my second time. Remember, I already had some additional factors from my previous work. So if I take f of x and I write it in factored form, it is going to look like this. X minus 1, x plus 1, x minus 2, x plus 2, and then I have to write it down below, but this is the polynomial's last factor, 3x minus 2. Those are also all of the zeros. So let's find the real zeros. The zeros are going to be 1, negative 1, positive 2, negative 2, and then that is going to be a positive 2/3. Now remember, way earlier, if I go all the way to the top of my page, remember I could have either 3 or 1 positive real root, or I could have 2 negative roots or none. So let's go see if that coincides with what the Descartes rule of signs gave us. So there you go. I had 2 negative roots right here. And then I had 3 positive roots. I had positive 1, positive 2, and positive 2/3. And that is how you are going to solve and find all the possible all the possible real zeros for a polynomial. I just want to zoom out because I want you to see all of this work at once. And that's it. I think that what I'm going to do is I'm going to box in my answer.